Hey everyone, welcome to part 4.5 of Breaking into Web Hacking in 2024. So today we're going to continue attacking databases with SQL injection attacks. Um, but this week we are going to be hitting blind SQL injection attacks. And like the name suggests, unlike last week where we got some sort of error message letting us know that there is a potential SQL injection attack that could happen here, in this case, we're not really going to get that sort of error response to confirm that it does exist. Instead, we're going to pay attention to the uh, the HTML that we actually are getting in return that's not an error. So by that I mean, so let's read this lab so you guys can get an understanding of what I mean by that. Let's start it. Uh, Blind SQL injection with conditional responses. This lab contains a blind SQL injection vulnerability. The application uses a tracking cookie for analytics and performs an SQL query containing the value of the submitted cookie. Cool. The results of the SQL query are not returned and no error messages are displayed. But the application includes a welcome back message if the page that returns welcome back message in the page if the query returns any rows. So in other words, the query has to be correct for it to get for us to get the welcome back message. And some things for us to note: uh, the lab is already giving us some useful information, so we're not going to have to do too much to confirm this. We're just going to take the lab's word for it. The database contains a different table called users with columns called username and password. You need to exploit the blind SQL injection vulnerability to find out the password of the administrator. So right off the bat, I know this is going to be a tedious lab. So let's just get it started. We're going to start the access. Burp's already fired up for us, so we're just going to wait for this to load. And let's look at the hint for us. You can assume that the password only contains lowercase and alphanumerical characters. Cool. So this is going to save us a whole lot of guessing. Making it lowercase is definitely going to help us out. That's if you have lowercase and uppercase, that you're essentially doubling the possibilities here. Cool. So the lab loaded for us. And just to make sure, I want to see where it was at. So this is saying it's on the tracking cookie for analytics. So let's take this URL, bring it to our Chromium browser. And again, this is the lab we just did in part 1 of SQL injection attacks here. Cool. So we have this loaded. Okay, this is our burp community. And we are gonna wanna take a response that has a cookie. Okay, so this one has a tracking ID. This is the one that they're referencing that is vulnerable. So we're gonna send that to repeater. Cool. And just to keep it simple for us, we are just gonna use the baseline here. Render it out. And we can see the welcome back messages here. So we're first going to use what we learned in the previous lab. We're going to use the single quote to verify for an SQL attack to see any differences. And we'll render this out. So like the lab description suggested, we don't see the welcome back message here anymore. So this is telling us that the statement, this tracking ID, where it takes this value and puts it into an SQL statement, is not properly completed or is not properly done in the back end. That's why we don't get the welcome back message. So we want to be able to confirm that there is an SQL injection attack, because this could just be any other thing happening in the back end. So what we are going to do here, we're going to give it a Boolean statement, meaning that we want something to return whether it's true or false. So we're going to give it an and. So this is saying that this value and whatever we give it. In this case, we're going to say 1 equals 1, a true statement here. I am going to give it the single quotes on the 1. What this is saying is the string value 1 is equal to this integer 1. Let's send it over. Oh, so we don't get the welcome back. I think it still needs the hyphens here at the end. Perfect. So it does need the hyphens here at the end after we get the 1 done. So as you can see, this is a valid SQL statement, which is why we get the welcome back message. And for your reference here, we're going to make this string 1 equals to integer 2. And as you can see, we don't get the welcome back message. So something we want to take a note of right here, right off the bat, is let's go back to the valid statement and look at the content length. So here we got 11,364. This is just the number of characters in here. And this is the number of characters when we get welcome back. So when we don't get welcome back, we have a completely different number. We have 11,303. And again, this is because we no longer have this welcome back down here. That's going to be important for us to keep in mind. Let's go back to that lab description just so that we know we're on the right track. To exploit, okay, to find the administrator password. Okay, cool. So I did prepare a couple of statements for us, and I'm just going to walk you through why I prepare these statements the way they are. Cool. All right, so this is kind of reviewing what we did last week, where this is the database, essentially the table with columns ID, username, password, with an ID 1, admin password 1. Just an example of what it looks like on the back end. So we already know there's a table called users, and we already have column names, username, and password. So when we create our statements, we want to make sure that these are exactly how the lab said they were. For example, let's just say instead of password, you put passwords. You're no longer going to get correct statements because that column does not exist. So again, want to make sure that these are correct in their spelling. And for our and statement, the reason we're using this statement is because we already know that this tracking cookie is true. So the and statement is just letting us know that this part has to be true. The second part has to be true for us to get the welcome back. And keeping that in mind, the next and statement we're going to look at here, we're doing another query. So this is selecting a, just an arbitrary letter from users. This is again the table users, where username, in this case administrators, is what we're looking for, and length. So we are querying the length function here on password. The password that is associated with this account is greater than 1. And if that is true, we are going to make a equal to a, which again is going to be a true statement. And if that's a true statement, then we are going to get the welcome back message, essentially. This is what this is saying. So we are going to just straight up copy this. And put this right into this statement right here. And again, this is reading that the tracking ID cookie and the select a from users, where username administrator and length of password is greater than 1 is equal to a. So if this is valid, when we send it out, we are going to get our welcome back right here. Cool. So just as we expected, this is a true statement. If it wasn't a true statement, what this would suggest to me as a tester is that I could log in as administrator without a password. So that would have made this lab super easy for us, but clearly it's not going to be that easy. So here we've proved that the password is at least 1 character long. What we want to do is determine how many characters is this password. So if we were to give an arbitrary number, like a large number, let's say 1,000, hopefully the password is not greater than 1,000 characters. Cool. So we don't get the welcome back message. Again, this is letting us know that the password is not at least 1,000 characters. So we do want to determine that, and I don't necessarily want to go 1 character at a time here, 1 number at a time. That could get a bit tedious. So I'm going to introduce you guys to Intruder. We haven't used this before. We're going to right click. That's what I did. And send it to Intruder. And what this is going to do is going to repeat a request as many times as we want it, with different kind of values that we're going to set it up for. So in this case, the parameter we are attacking, the value is this password length. So we're going to add this squiggly s before it and a squiggly s after it. So this opens up the statement and this closes it for us. So this is what this is saying, is that this could be the only parameter here for us that's actually going to change. And we're going to use a sniper attack. There are other types of attacks here. But a sniper, all it does is just a single set of payloads on one value. In this case, we give it 1. Now we're going to go over to the payloads column. And these are numbers. So they conveniently do have a number for us here for values. And we're going to take it from value 1 all the way up to 30. Hopefully it's not 30 characters long, but we are going to start it with 30. And step is how much you want that value to increase by. So we are going to start it here with 1. It's going to go up to 2, then 3, then 4. And we're going to start this attack. So you're going to get, if you're using Community Edition, you're going to get this alert message. And all it's saying is that these attacks are time throttled, meaning that the more requests go out, the slower it's going to be for us. So in this case, it's moving relatively fast. It's only 30 requests. And we can already see, let's pay attention to this length column. This is, again, that content length we were talking about before. And let's look at the length. So we can see here that it starts changing at 19 and 20. So we can click on that. You can really see it pops up the request for us right here. And the request is reading and the tracking ID where administrator and password length is greater than 19. So in other words, this is still a true statement. We get the welcome back. Here we can see the welcome back, but we no longer get it at 20. So 21, 22, and just for confirmation, let's click that response, render it out, and boom, we don't see the welcome back. So what this is saying is that if the length of the password is greater than 19, but not greater than 20, then the password length has to be 20 characters long. So just as a placeholder, we're going to put 20 hyphens. Boom, boom, boom. 20 hyphens here. And this just represents for us right now the unknown password that we have. So let's start that out. Cool. So far we just know the length of the password. We don't know anything else, but we're going to continue doing very similar attacks to this to determine the placement of each letter within that password field. So the next statement that we are going to cook up is the second select statement. So let's read it so that we understand exactly what's going on. So again, we have this AND function, and we're selecting from the substring, meaning from the substring of the password, from the password column, the first value in there. So in this case, it's password right here. And it's checking each one at a time. It's grabbing that first value that we see here. From users where username equals administrator, return A. Administrator user is equal to password is equal to A. Perfect. So what this is saying is if this has the letter A as the first placement, then this statement will be true. And if this statement is true, we are going to return that welcome back message. And this is going to be a tedious process to do one letter at a time. As we can see, it uses lowercase letters and numbers. So if you think about it, there's 26 letters and digits. We got 10 digits. So that's 36 different possibilities for each one of these. So we're not going to brute force that. What we are going to do is we're going to use these SQL statements. Let's do the control copy and go over to our burp. Go back to that repeater. And we're going to paste this SQL query right here. Perfect. So we want to make sure it still follows the proper syntax for us. Again, if this is true, like let's say the first letter in our password is A, we are going to get back the welcome back message. And if it's not A, we're not going to get the welcome back message. Cool. So we don't get the welcome back message as expected. Let's try B. Again, we don't get the welcome back message. We'll try C. Still no welcome back message. And as you can see, this is going to take a long time doing one letter at a time per position. So we are going to, again, send this over to intruder. Boom, here we have it. This time, let's pay attention to all these other kinds of attack types. So we have the sniper, which is attacks one payload with one position. This one uses battery RAM, uses a single set of payloads, and it iterates through the payloads and plays the same payload into all defined positions. Meaning that in this case, uh, we are going to want to run through two different values, which is the one and the letters here. So we are going to already place the S right by that one, and then we're going to place the S between and after the A, which is the character that we are going to iterate through. And we don't want a sniper attack. We don't want a battery ram because this is just going to use a single set of payloads. What we do want to do is create an attack where this number goes up by one. So it starts at one, then two, then three, then four for every letter. And then it iterates that again with a different letter. And it's just going to keep doing that for us until we get the correct all the welcome back messages. And once we have all the welcome back messages, we're going to be able to piece together what that password is. So sniper is not going to get the job done for us. Battery ram is not going to get the attack done for us. uh, Pitchfork, this attack uses multiple payload sets. There's a different payload set for each defined position. Maximum 20. The attack iterates through all the payload sets simultaneously, so it uses the first payload from each set, then the second, and so on. So this one could work. It's just going to be a little bit disorganized. Let's look at Cluster Bomb. This attack uses multiple payload sets. There's a different payload set for each defined position. The attack iterates through each payload set in turn so that all permutations of payload combination are tested. So this is the one I like for this attack, meaning that we are going to start with one. It's going to test every letter with one. Then it's going to test every letter with two, then three, and so on and so forth to make sure that everything is tested for. So we have the cluster bomb. We have our two payload positions set for us. Now let's go to our payloads. Here we can pick which payload number. Let's start with one. And again, we're going to run through those numbers. This time we do know that the length of the password is 20. So we're going to go from 1 to 20, step 1. And now we're going to choose the second one. So for the second one, the option I want to use for that, since we know it's all lowercase and all numbers, we're just going to go for the brute forcer. The brute forcer already has the lowercase letters for us. The only thing we have to change here, so you see here the length. We want the length to be 1 because we only want the characters to be tested one at a time. So we want the minimum length to be 1 and the max length to be 1. So we can already see here, this is what I mentioned. We have 36 different payload counts, and we're doing a total of 720 requests. So we can confirm the password for this. This is a little time throttled, so we'll see as far as we can get with this attack. So you can see here, we can see the length. These are all the same so far. Ooh, we got one different one already. One different response. Let's see what we get. We get the welcome back there. And here we can see that 12 is equal to A. So A is the 12th character. So what we're going to do is go back to our notes here. We had the 20 different hyphens. And we are going to go to number 12 and change that to A. So we got one letter down so far. We got 19 more to go. What we are going to do to make this a little easier for us, we're going to sort the length so that the payloads that are working for us, that are returning the welcome back, are going to be at the very top. So we got this one first, the 12 and the A. Then we get this one. B is number 17. Oof. 17. All right. Perfect. 18, 19, 20. Perfect. All right. Oh, wow. We're getting a lot of good ones here. So we got A. We got B. D is in 3. Let's go back to here. To 1, 2, 3. Beautiful. D is 3. Oh, D is also 4. This is like playing Hangman here. Doesn't look like it's going to make a word. I'm trying to think of words that have a double D in the beginning or 20 characters long, but doesn't look like it. All right, so as you can see, this is what I mean by the time throttled. Every request now is going to take a little bit more time. We're just going to go up to 100 requests and see what we come up with. I don't think we're going to get it solved within the 100 requests, but it is worth trying out. And just to confirm with you guys, this is the one that's not working. And if we click the response, we do not get the welcome back message. And again, for this one, we do get the welcome back message. This is what letting us know that the character does fit into that position for the password. Um, oh, another way to look at it, I just realized this here for us. On payload one, we do have the number, and on payload two, we have the letter. So I could just match up here the number and the letter to the correct password here to our notes. And again, we're just going to let this run. We're already at the 101 request, and it's not looking too promising for us to solve this relatively quickly. So we're going to wait one more. We get one more character, and then I'll let you guys finish this out on your own time, really. You know, we are using the community edition. If you use the pro edition, this will get it done in absolutely no time. But community edition, we do have to deal with this. All right, we're up to 110 requests. We still haven't got, oh, we got one more hit. F is 10. F is 10. Boom. All right. So far we got 25% of the password done for us here. Um, yeah, I think there should be enough information for you guys to be able to handle this lab on your own now. Just to give you guys a summary of what we did today, we confirm a blind SQL injection attack using some sort of Boolean function in the background, meaning that something that we know we can test as either being true or not true. In this case, we used the and 1 equals 1 to first test it out, and then confirmed it with 1 equals 2 to see any sort of differences in the responses. And then we use that to be able to figure out other statements, such as the length of the password and then the position of certain letters relative to where that password is. So in this case, we see B is position 17, D is position 3, we got D is position 4, F is 10. And I'm going to want you guys to follow that logic straight through for every single one of these letters. You're just gonna have to wait out if you're using community edition, you're just gonna have to wait it out and fill in the blanks. But that's all for today. Hope you guys learned a thing or two about blind SQL injection attacks and can use this to go out and find some of these out in the wild. But for now, that's all. Peace, bugs, and muscles.